If we assume, based on the facts, that consciousness is located in our brain, we could very well be wrong. How did we arrive at this valuable conjecture? In 1980, neurologist John Lorber was working as a professor at Sheffield University when he was visited by a young man suffering from a severe headache. Upon conducting tests, he discovered something that is still somewhat surprising today. The patient complained of a persistent headache and was unable to concentrate. And this discomfort drove him to despair. Dr. John Lorber used a computed tomography scan to examine the university student's brain. The doctor was very intrigued, reviewed the young man's medical history, and discovered he was brilliant. This student had an IQ of 126, led a normal life, and had graduated with honors in mathematics. It's worth remembering that Einstein was considered to have had an IQ of 120. When Lorber performed the CT scan, he discovered he suffered from extreme hydrocephalus. This means that his cranial cavity was flooded with cerebrospinal fluid and contained only a thin layer of brain tissue. This finding was surprising because, according to conventional wisdom, a person with such a small brain mass should suffer from severe cognitive impairment. This student with hydrocephalus basically had a 1 mm layer covering the inside of his skull, and that constituted his entire brain. In other words, it was a virtually non-existent brain. This student's brain tissue weighed approximately 100 grams, while the normal adult brain tissue weighs at least 1,500 grams. How was it possible that, with this tiny number of neurons, he was even able to articulate a word? But the facts revealed that, instead, he had an IQ above the average human collective. He graduated with honors in mathematics and led a normal social life. It's worth mentioning that this person's medical condition remains a mystery in neuroscience, and it continues to raise many questions about whether the brain is capable of functioning with such a small amount of mass. Dr. Lorber published his findings in 1980 in the scientific journal Science, in an article entitled, "Is Your Brain Really Necessary?" In the article, he not only presented the case of the student with hydrocephalus, but also several other similar cases who lived normally, showing no signs of cognitive impairment. This publication generated a great deal of debate in neuroscience, as it challenged traditional ideas about the relationship between the brain and consciousness. But experts didn't want to contradict what they knew about the brain. So, they coined the term neuroplasticity, to establish the possibility that the brain could function without so much mass. But if the brain can function so efficiently with so few neurons, then why do we have such a large brain, with an astronomical number of neurons? Neuroplasticity isn't the name of a phenomenon we see, like rain. Neuroplasticity is a name inferred from something that's supposed to happen. It's an attempt at a theory to explain the inexplicable. It was used to clarify how the brain adapts and reorganizes its functions, with the assumption that it does so, but without knowing how. But in extreme cases, like those discovered by Dr. Lorber, it seems more like a clumsy and awkward hypothesis than a scientific explanation. When someone with only 10 grams of brain can lead a normal life, neuroplasticity is a very poor hypothesis. Some say the brain reorganizes itself and finds a way. But that doesn't really answer the question. How it does it, or why, is it possible? This is similar to saying, gravity causes objects to fall. Yes, but why do they fall? Neuroplasticity is just a label applied to the inexplicable. This convoluted label describes the phenomenon, but with no idea what it is. We still don't have the right framework for understanding consciousness and the brain. This leads us to the fringe of knowledge, to its limits. But this interesting phenomenon gives us material for valuable conjecture. Is it possible that consciousness can be housed in some brain matter we can't see? Let's make an analogy. Today's computers are capable of running game programs, displaying intricate graphic effects, and performing thousands of complex calculations in fractions of a second. If these highly advanced game programs were to run on a decades-old machine, such as, say, an XT computer, which had much less memory, with just 128 kilobytes of RAM on the motherboard and a Seagate hard drive of just 10 megabytes. Obviously, it would never run. That decades-old XT computer would be very primitive. The hardware would be too small for the software. Today's personal computers can have between 4 and 8 gigabytes of RAM, and between 250 gigabytes and 1 terabyte of hard drive space. The amount of memory and processing speed of today's computers is thousands of times greater than that of the computers of yesteryear. The same would be true for a small amount of brain matter. The thin strip of brain matter, with an extremely small amount of gray matter, constitutes tiny hardware for performing the complex tasks performed by a mind with an IQ of 126. It's worth mentioning that the entire brain contains the neuronal cell bodies necessary for information processing and decision-making. And the white matter is composed of myelin-coated axons, which connect different brain regions and allow for rapid signal transmission. The brains of the human collective are infinitely sophisticated, far more so than the most complex computer ever built. So, how is it possible for a jumble of neurons to more than satisfactorily perform the same tasks as a healthy brain packed with billions of neurons? It's simply not possible. So, in light of these facts, consciousness would need to emerge from extensive hardware, which clearly cannot be perceived in the brain of the student with hydrocephalus. Many scholars are considering that, due to these cases, our consciousness may reside outside our brain. But we are biological organisms that require a structure to function. In this case, biology transcends the realm of the observable. Quantum entanglement and tunneling phenomena have already been discovered within the cells of living beings, more specifically, in enzymes and chloroplasts. And biological phenomena continually amaze us. This leads us to the idea that the only possible solution is that there exists a brain structure that we do not perceive near our skull, whose neural connections are built beyond observation. Could it be constructed of some material that we cannot detect or perceive? This idea is not completely far-fetched. We now know that there is a certain type of matter that is beyond our perception, that is all around us, permeating everything, between the stars and galaxies. We now know that all the matter we perceive constitutes barely 4% of everything that exists in the universe. The rest interacts with us and with the galaxies, and we know this from their gravitational interactions. This exotic matter, so to speak, exists, but we don't see it. And it's been given the unfortunate name dark matter. But in reality, it has no color. We simply can't see it, nor do we sense it. Therefore, there is strange matter that forms systems, that connects exotic neurons. We don't see them, but we know they're there, because of the consciousness generated. But the individuals who are capable of constructing a mind, through merit and will, are very few. Most hydrocephalics don't succeed. Very few are saved, and they are those who persist in continuing to exist. Our biology uses natural laws. It is what it is. To construct being. And this is the great conjecture. All of us, to a greater or lesser extent, construct our mind, our essence, our self, or as some would say, our soul. And this is very important. Because, to become, we must know ourselves. And in knowing ourselves, we build ourselves. In building ourselves, we change. And that happens when we improve, when we evolve. And that structure, primarily, grows with us. Even if we don't perceive it, nor do our doctors see it. And it happens that, in other individuals, the less fortunate, it doesn't grow at all. Knowledge at the limit, at the fringe, forces us to make educated guesses. Our brain performs functions that often cannot be explained by its size or its amount of memory. It seems to need more hardware and more power than it has. And here's the explanation. Inspiration. By solving problems that not even computers can solve, it would use a more sophisticated brain. That we can't see. But not everyone is saved. Not everyone builds their being. We are born without a soul, or with a soul in the making, with a being so scarce that it takes years to build something better. It's an effort. It's merit. Because salvation isn't something we already have from the moment we are born. It's something that is built. Only the little turtles that fought to the end managed to leave the sands of the beach and enter the sea. The world and its interactions are basically natural and function according to their laws. Although we don't know all of them. This means that salvation is a natural event. But what about the rest of normal people? Are they capable of constructing a self? Or do they live in fantasies? We must clarify something. The person, the individual, is the one who seeks evolution and exploration. They must overcome the inertia of the genius of the species, which tends to be reluctant to allow us to change. The self must move away from that animal nature, which consists only of reproduction, of pressing the onanic and hedonistic button. By being naturally celibate, and by knowing ourselves better, we are able to move in directions that are often difficult to explain to the collective. For feelings toward the world and people, often very different. Each self has a purpose. We come to this world to explore and become. But the question remains, are the drones of the collective capable of constructing a self?